All right, in this video, we are given 3 points here, A, B, and C, and we need to find the vector, parametric, and Cartesian equation of the plane that passes through these 3 points. So let's start with the vector equation first. In order to find the vector equation of a plane, you want to start by finding 2 vectors from the given 3 points. So you can either find AB or AC or BC. It doesn't really matter. There's multiple possible solutions for a question like this. I'm just going to find AB first. And in order to find AB, you should know how to do this calculation. It's just B minus A. So if I subtract -2 minus 1 is -3. 4 minus -3 is 4 plus 3, which is 7. And then -2 minus 2 is -4. Let's find our second vector now, which is going to be BC. But you could have also done AC in this case. Answer would be slightly different, but like I said, multiple possible solutions for a question like this. BC is just C minus B, so I'm just going to do C minus B. So 3 minus -2 is 3 plus 2, which is 5. 2 minus 4 is -2, and 1 minus -2 is +3. Once you get your 2 direction vectors, you can simply write out your equation for your plane. So R equals, you can pick any one of these 3 points. It doesn't really matter which one. Like I said, multiple possible solutions. I'm just going to pick A, but you could pick B and C as well. So you want to first put a point on the plane and then add the direction vectors, and you want to use different letters for the direction vectors. So I'm going to use T over here for the first direction vector and S for the second direction vector. And you also want to state that both T and S, I don't know if your teacher makes you do this. Some classes do, some don't, but T and S are both an element of all real numbers. Generally speaking, this is implied though for all vector questions, so some classes may not require it. Now that we found the vector equations, let's go to the next part of the question, which is finding the parametric equations for these. So in order to find the parametric equations, we just break down the x, y, and z components from the vector equations. It's pretty much that simple. So let's start with the x component. So x equals, the x component of the point is just 1. The x component of the direction vector with the t is -3, so minus 3t. And then the x component of the direction vector with the s is just 5. So plus 5s. Then let's do it for y as well. So y equals, the y component of the point is -3. Over here for the t direction vector, it's +7, so plus 7t. And then for the s direction vector, it's -2, so -2s. And last, let's do it for the z component. That's 2 minus 4t plus 3s. And these are the parametric equations for this plane. Let's go to the next part of the question, which is finding the Cartesian equation of the plane. So we know that a Cartesian equation is ax plus by plus cz plus d equals to 0. This is the Cartesian equation of a plane. the first thing that we generally do in these kind of questions is we find A, B, and C, the direction vector of the normal to the plane. Okay, so or the not basically called the normal vector. So in order to find the normal vector, we have to cross multiply the two direction vectors we had initially in the question. So I'm going to cross multiply these two direction vectors over here. I'll show you how I do cross multiplication, but there are a lot of different ways to do cross multiplication that might look slightly different from this one. For me, I write the two vectors above each other. Then I start by multiplying out. I hide the first column and I cross multiply the second and the third column. So I have 7 times 3 minus -4 times -2. I just subtracted the cross multiplication of these two over here. 7 times 3 is 21 minus -4 times -2 is +8. And that is just 13. So the x component of the cross multiplication of these two vectors is 13. Next, I'll do the y component. For the y component, I start by putting a negative sign. Then I use a square bracket, and then I hide the middle column, and then I cross multiply again, like that. So if I hide the middle column and I cross multiply, I have -3 times 3 minus 5 times -4. That's just -9. 5 times -4 is -20 times negative is +20, which is just -9 plus 20 is +11. So the y component of this vector is -11. Finally, I'll find the z component by hiding the final column and I'll cross multiply over here. So I have -3 times -2 minus 7 times 5 or 5 times 7. I want you to note that only the y component has a negative sign outside the whole thing. X and the z component are just subtractions of the cross multiplication. This is 6 minus 35, which is -29. So my direction vector here of this cross multiplication is 13, comma, -11, comma, -29. And these over here, when you cross multiply two direction vectors, you're going to get the normal vector, which is the A, B, and C of my Cartesian equation. So I have 13x minus 11y minus 29z plus d equals to 0. Now the Cartesian equation is almost complete. The only thing missing is we need to find the value of d. In order to find the value of d, we can sub in any point on this equation, basically any one of these 3 points, any one of them for x, y, z, and solve for d. I'm just going to sub in the first one here again. Again, no real difference. If you have a point that has smaller numbers, you generally want to use that one so your calculations are easier, but pretty much same difficulty. So I just subbed in A for my x, y, z here, and now I'm going to solve for d in this question. So I have 13 plus 33 minus 29 times 2 is 58. Then I'm going to combine these three like terms. So that's 46 minus 58, which is -12 plus d equals to 0. I'm going to move the -12 to the other side, so d just equals to 12. And now I'm going to rewrite my equation as 13x minus 11y minus 29z plus 12 equals to 0. This is the Cartesian equation of the plane. And the last part of this question asks us to determine whether the point 3, 5, -4 lies on this plane or not. So in order to prove whether this plane lies on this plane or not, I just have to summon this point over here. And then I just have to solve this and check whether it equals to 0 or not. I'll just do this in my calculator. And I get 112 equals to 0, which is obviously not true, which means that therefore the point does not lie on the plane. If I got 0 equals to 0, it would mean that the point lied on the plane. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.